Welcome to one and all. Today we are going to see the how to solve the assignment model or assignment problems in a quantitative techniques and management. As we already know regarding the special cases in assignment problems, we already saw the one type in special cases in assignment models or problems is called as unbalanced problems. Now today we are going to see the second special cases in assignment problems is known as a maximization problems, in which the Hungarian methods for maximization problems can be used to solve the maximization problem as follows. First, convert the given profit matrix into a relative loss matrix, that is called as opportunity loss matrix, by subtracting all its elements from the largest elements in it, including itself. Second, solve the further using Hungarian methods to get the optimal assignments. Third, to find the total maximum profit, consider the original profit elements for the respective assignments. So here the given problems. The following problem for the maximization production output. The data refers to the productions of an article for the given operators and machines. So here the operators are given to us, a number of operators are given to us 1, 2, 3, 4, 5 with respect to the machines A, B, C and D. So first always look whether the given matrix table is balanced or unbalanced. First check it out, write down the in new matrix table. The given problem is a maximization and is a unbalanced also. Hence, add the first dummy column to it with all its elements as a 0. So add the first dummy column with the values 0 for all. Then next, identify the maximum value among these all the opportunity cost. So here the maximum values for it is given to us is 11. So our next step is convert the production matrix into a relative loss matrix by subtracting each of its elements from the largest elements in it, that is 11. So convert into the relative loss matrix table. So here we identified it, the largest elements is already given to us is a 11. So subtract all other values from the largest elements. So for first 11 minus 10 comes 1, then 11 minus 5 comes 6, 11 minus 7, 4, 11 minus 8, 3, 11 minus 0, 11. Next, for next row, operator 2, 11 minus 11, 0, 11 minus 4, 7, 11 minus 9, 2, 11 minus 10, 1, 11 minus 0, 11. Next, 11 minus 8, 3, 11 minus 4, 7, 11 minus 9, 2, 11 minus 4, 11 minus 7, 4, 11 minus 0, 11. Next, 11 minus 7, 4, 11 minus 5, 6, 11 minus 6, 5, 11 minus 4, 7, 11 minus 0, 11. 11 minus 8, 3, 11 minus 9, 2, 11 minus 7, 4, 11 minus 5, 6, 11 minus 0, 11. So this is your new matrix table with the relative loss matrix values. So now next, apply the Hungarian methods or flood techniques. Remember always first step 1, our row subtraction. So select the smallest value in each row and subtract the value from each value in that row. So in a first row the minimum value is 1. So subtract this 1 minus 1 comes 0, 6 minus 1 5, 4 minus 1 3, 3 minus 1 2, 11 minus 1 10. Next, for next row, row 2, the minimum is 0. So all values are remains as it is. So 0, 7, 2, 1, 11. Next, move on to operator 3, row 3. The minimum is 2. So 3 minus 2, 1, 4 minus 2, 2, 2 minus 2, 0, 4 minus 2, 2, 11 minus 2, 9. So next move on to operator 4, row 4, minimum is 4. So 4 minus 4, 0, 6 minus 4, 2, 5 minus 4, 1, 7 minus 4, 3, 11 minus 4, 7. Next move on to operator 5, row 5, the minimum is 2. So 3 minus 2, 1, 2 minus 2, 0, 4 minus 2, 2, 6 minus 2, 4, 11 minus 2, 9. So here we completed our step number 1, that is row subtraction. Now move on to step number 2, the column subtraction. So column subtractions identify the minimum value in each column. So you can clearly identify that in column A, machine A, the minimum is 0. For machine B, minimum again 0. Machine C, minimum again 0. Machine D, minimum is 1. And dummy, minimum is 7. So subtract these minimum values with respect to that column values and write it down again the new matrix. For A, the all values remain as it is because the minimum values is 0. So remain as it is. So for B, move on to column B. Again the values remains as it is because the minimum value is 0. So next again column C, the minimum is 0, again remains as it is. Next for column D, the minimum is 1, so 2 minus 1 value is 1, 1 minus 1 0, 2 minus 1 1, 3 minus 1 2, 4 minus 1 3. So next for dummy, minimum is 7. So 10 minus 7 3, 11 minus 7 4, 9 minus 7 2, 7 minus 7 0, 9 minus 7 2. So here we completed our step number 2. So move on to step number 3, draw the lines which covers the maximum number of zeros. So here by observation or by inspections, clearly know that the maximum zeros lies in column A. So draw the vertical lines which covers the maximum number of zeros. Then next move on to row 2, operator 2. The single zeros are lies, so draw the horizontal lines which covers the maximum number of zeros. Then next move on to row 3, again lies single zeros, so draw horizontal lines which covers that particular zeros. Then next row 4 having the single zeros, again draw the horizontal lines which covers that particular zeros. Then row 5, operator 5 having single zeros, then draw the horizontal lines which covers that particular zeros. So here your number of lines is equal to your number of rows and columns. Your number of lines are 5 is equal to 5. Therefore our solution is optimum. Then next move on to assignment. Step number 4, make assignment. So operator 1 you are going to assign to machine A and cancel out the other successive zeros which are represented in a respective column wise as well as the row wise. So cancel it out. Then next operator 2 is going to assign to machines D, and operator 3 you are going to assign to machine C, and operator 4 you are going to assign to dummy, and operator 5 you are going to assign to machines B. So write down in the next table. Operator 1 you are going to assign to machine A with the original values 10, operator 2 to machine D with the values 10, operator 3 to machine C with the original values is 9, operator 4 to dummy 0, operator 5 to B with the values 9, and summation of this is 38. So I hope you all of you better understand how to solve the maximization type of special cases in assignment problem. Thank you.